Hey guys, what's up? Are you 1 or 0 here? So, another week, another video on reverse engineering 101. It's going to be another simple video. We're going to cover two crack me's, but in the previous video, we used Windows as operating system to reverse the binary. And this time, I'm going to walk you through two Linux crack me binaries. And we're going to use either free version. I'm going to show you how to install it on a Linux box and how we can walk through to do reverse engineering on two very simple binaries. We're going to check the assembly code. We're going to walk it through so that we can understand what's going on when we're reversing a bit more. We're going to also go through the C code, the source code of the binary, so that we can also understand before we start reversing the binary, what does it look like. So we're also going to cover structures, how we can create a structure, an IDA, and how we can apply it to a pseudocode. So there are going to be a few more topics that I didn't cover in the previous video. I know that these are like super simple. I'm finding like the easiest scenarios possible. But the thing is that we can start from a heavy topic, so we can just like go through very easy scenarios, understand IDA, get familiar with it, and I'll also cover different tools like Jidra. Uh, I'll try to use free tools so that anybody can be able to replicate these scenarios in their own machines. Enough with the chit chat. So let's jump into two scenarios that we're going to cover today on our Linux environment. So we're gonna start with the easy level first. As you can see, I downloaded the binary and the source code already from crackme's website. So this is the executable. As you can see, it has the privilege X. If you don't have it, just change it with this following comment plus X crackme1. This should give you the executable privileges as well. So we're going to see how the program behaves first of all by typing the name of it. As you can see, it asks for user input, enter key, you're writing a value, and it says sorry, right? So let's see the source code and what do we see in the C program, little C program. So as you can see, there are two functions, one of them success, which prints the value congrats, and other functions fail, which prints the value sorry. What happens in the main function is that they they define a key variable, asks for the user input, enter key, and then it compares this key variable that's been provided by the user with 2337. If if it matches, then it returns the success function, which will print congrats. Otherwise, it will fail. Very simple program. We know how the program behaves now. So we're gonna fire up IDA here. I already installed the IDA free version. As you can see, we have the 64-bit file in here, IDA 64, and this is 64-bit. Linux machine that I installed in here, which is Remnucks. If you're not familiar with this is basically Kel Linux version for malware analysis or reverse engineering. So you can use this tool, you can use this machine. It's pre-installed most of the tools that you're going to use. So it's a pretty cool one. I would suggest that. So what we're going to do is that we're going to run IDA. I'm going to use the following command so that I can use this tab, this command line, the terminal later. If you add this one, you're not going to be blocking this terminal basically. All right, so we're starting it. IDA starts. I'm saying okay. Going to the first exercise, which is crackme.one, the simple one. Let me show you what I meant by here. As you can see, you can still use the terminal. That's why we use this option. Anyway, IDA detected already some information such as ELF64, 64-bit binary, and of course ELF is the header for all these Linux binaries. Detected some default options, but you don't have to change anything for the simple exercise, and we started IDA. As you can see, it always starts with this graph view, so the start of the program. So there are some functions being called print function, which is obviously asking for user input, and then making some comparison with EX register and some value. If you don't know what this value means, you can just right click to see different variations of such as decimals 2337 or different variations for binary, etc. So I would definitely suggest you to use that. If you just want to see the decimal version, you can just click on H as a shortcut, which will show you the value as well. Just click on H again to change it back to default. As you can see, there's a comparison happening in here with the value in EX register and with the value that needs to be matched. We're seeing in the previous instruction that we're putting a value, a pointer, and RBP plus for C to AX register, then we compare it with the value that we want to match. So this value that's been pointed out on here is going to be our user input that's been shown in the previous instructions. So then what happens, there is going to be a jump not zero instruction, which is going to whether go to a success or fail nodes. As you can see, this is the default path that is going to go, default node that's going to go, which goes to this function, which is the failed function, right? So if you remember, or if you watched the previous video, we can do this pretty easily. We can patch this program pretty easily by just changing jump not zero to jump zero, which is like a pretty easy trick on these easy assembly programs. We're gonna do that, but after this I will include another easy crack me, then we can also dive into a bit more assembly code. Okay, let's start with this one. If you don't remember how to use IDA, it's basically a reminder for you. We're going to start the program, but make sure that the debugger is chosen as local Linux debugger. In the previous video, I also included a remote Windows debugger because I was reversing in my Mac and I was using a virtual machine, which was Windows, right? In here, we're using IDA free, we're using local Linux debugger. One thing to show, for instance, let's go to one of these functions. I clicked on printf by double clicking. If you don't want to be here, if you just want to go back to the previous location, you can just click on escape, which will take you back to the previous location. If you click on escape multiple times, it will just take you back to where you were before. So just a little trick. What I'm going to do is I'm going to click on this and I will put a breakpoint. Shortcut for breakpoint here is F2, but if you don't remember it, you can always right click and put a breakpoint like that as well. It's going to put this red line in here and you're going to start debugging, right? If you go back to your terminal, it will just ask for your key, which means debugging process started. I will just put some value, and as you can see, we got this message, IDA is ready, and that means it hit the breakpoint, which we put before already. You can click on space to put it back to the graph view as well, which allows us to see which direction it's about to go, which is going to be failed, right? What we can do is that we're going to go there, click on edit, patch program, assemble. Somebody asked like, you're not patching it, you're just changing one instruction. So right, I think I forgot to mention this. After I change this from jump not zero to jump zero, okay, and checking if it's working for our solution, you can go there and say apply patches to input file. So that's going to be the final step that you need to do after you change any assembly code. So right now we're in here. If we click on F7, we're going to go to the left side, which is going to be success. If you click on F9, which is going to take you through all the steps, as you can see, you got the congrats comment in here. Pretty easy exercise. So that was the solution for the first one. I'm just saying don't save the database. I don't want to save any of these options in here. So I'm just gonna go back and right, so we will go back to the second exercise, crack me to, wait, where are we? Which direction to crack me to? Let's see. So what we're interested in these two files, one of them is this executable crack me. Let's see, it's not executable yet, so we're gonna change the permissions for this file, but that option crack me to. It should be executable now, so I'm going to run the file. It asks for a key. I'm writing a random value. Then it asks for serial. Obviously, it tried to match with the correct value first, which I failed in the first step anyway. It didn't even ask for serial. It just posted the prompt here and set wrong. So obviously we're going to go through the source file first. Let's go that. So let's see what's happening in here. So there's a struct defined in here, structure defined key and serial variables. There are two functions we have: success, which is going to print correct, and fail, which is going to correct wrong, right? Let's see the main function, what's happening in here. Key and serial variables are initiated, and then struct is defined in here, structure with kb, and kb.key is defined as this value, and kb.serial is defined as this value. It's going to prompt the question, enter key to the user, and store the variable key, and then it will ask for serial as well. If the key that's been provided by the user is matching with the value that's been defined before, which is the right key and the right serial, then it's going to run the function success, otherwise it will do fail. Pretty easy, pretty straightforward. The only difference is that we define some structure in here, which we're going to use in IDA as well. There are two variables instead of one, which is better, more challenging. And now we're going to see more changing the variables, decompiling, creating pseudocode, etc. So we will see a few more stuff compared to the previous challenge. So as always, I'm starting IDA with the following comment. Starting it, going to crackme2, start it with the default option, saying OK, and IDA Pro initiated, right? So what we can do in here is that first we're going to see the flow. Where does it go? After that, we're going to see how we can create a pseudocode and how we can change variables and rename variables in IDA. So that's the start of the function. As you can see, it prints 2 times, means asking for like user input, the prompts in here. The function works in a way that when you enter the serial, this function is called. At the end of this node, as you can see, it's again comparing EAX register with EDX register, and then makes jump not 0, which goes to here, and makes some operations in here. At the end of it, it makes again another jump, which just goes to success or fail. So if you remember from the code, where was it? It should be in here. So the first node, make jump not 0 to the function in here, is going to be this one. So you'll enter the value, it compares something, and it jumps to here, right? That's why we are seeing only one node. If you're writing the wrong value in here, it automatically goes to fail. Calls this function. So if you write the right value for the key, it goes to the left side, and it asks you for the serial. If you are writing the wrong serial, it calls the function fail again and goes here. Otherwise, it goes to the success. Pretty cool, like 2 steps this time. So what I want to do is that we already have access to the source code, right? We already checked it out. But imagine that you are in a black box and you do not have the source code. What we're going to do is that either we're going to decompile it, or we're going to briefly check the pseudocode. I'm clicking View, Open Subviews, generate pseudocode, or the shortcut is F5 on Linux. I'm clicking on this and it created the pseudocode and the new tab. So let's see what's going on in here. We will try to read this code and we will rename the variables with the shortcut N for name, right? So let's see what's happening in here. There's some variables defined in here, but it's so vague right now. V8, V4, what are these, right? So we need to change it a bit. So it asks for enter key and then puts V4 as the key. So that means V4 is the key, right? So I'm just pressing on N and changing this variable as key. Oops. Yeah, if you're using a German keyboard on your Mac and Linux is common English, that happens. So when I say OK, it changes every single v4 variable as key. So that's the cool thing about IDA. Then it asks for serial and it stores it in v5. That means v5 will be serial. And I'm clicking on N again. And for name, then I'm saying serial. OK. It changed everything again. It's easier to read right now. So what we're going to do is that there is a structure defined, right? So we're seeing V6 and V7, and we're trying to define what these are. What I'm going to do is I'm going to go to struct. I'm going to add a new structure in here. Struct name, I will call it keybank. Okay, if I can type properly, I will say okay. So what I'm going to do is I'm going to click on ends. So I'm going to click on D. It started with the bytes, the word. I'm looking for double word, and I created the first field already. So I'm going to click on this. So call this key. Cool. The second one, again, I'm clicking on ends and adding and pressing on the button D until it becomes DD, and clicking on field 4, pressing on N, and changing this to serial. Okay, and we added our first structure with two variables, key and serial here. Go to my pseudocode, and I'm going to click on V6 and V7 by pressing the button Y for them to be interpreted as a structure that I created. I'm clicking on Y, and I will say keybank, clicked on it, set the type, and it says key and serial. As you can see, it already interpreted in here, much similar to our program, right? All right, we can also change this V6 by clicking on N. Let's make this an lowercase keybank. As you can see, it's even easier to see in this way. It's struct, and this is the structure for it to detect the variables from struct, right? Much easier to read in this way. What we're gonna do is that I'm gonna put the pseudocode in the same screen as IW. What I'm gonna do is that I'm gonna move this. As you can see, IDA will show where to put, whether top or right side, left side. I'm going to put it on the right side, right? So let's see what is going on in here. It's going to be easier to synchronize with. When I click on right, I will right click, I will synchronize with IDA view, hex view, which will basically show every single changes that I made on the variable names on the left side. Another thing that I wanted to mention is in assembly, as you can see, there are some call functions in here, right? Call instructions. So every single instruction that's been written before call is gonna be the instructions for the call function that the function that we're calling in here. So there are 4 instructions that we're seeing in here with the move, moving some variables or pointers to the registers, and these are going to be used for this function that we're going to call later. So cool. Few ways to do that is one of them, I will put a breakpoint in here with F2 and put another breakpoint in here. So I'm assuming when I go through this pad, I'm gonna go to the left side first, so I wouldn't end up with fail, and then I will debug it again, reverse it again until I reach out to success, right? So what I'm gonna do is I put 2 breakpoints. I'm gonna start the process. I'm gonna say yes. The debugging screen started. If you go back to your IDA terminal, it's going to ask for a key. I'm going to write A. It already hit the breakpoint, the first one, and it says you're going to go to the right side, fail, right? The first thing we're going to do, we're going to patch this program. I know that I'm showing the same method in the first videos, but don't worry, guys. I'll show other methods as well. So it's not only changing jump not 0 to jump 0. It's just the simple scenarios, and generally the solution is similar. It's just that we're getting more comfortable with IDA and we're learning more about assembly. So I'm clicking on OK. Then I will step through with F7. As you can see, we ended up here, not with fail. I will continue with F7 step by step. We're comparing now the serial. We already compared the key bank, the key information, and since we change jump not 0 to jump 0, we end up with success. Otherwise, we wrote the wrong key anyway. So I'm doing one more F7 to hit the second breakpoint. As you can see, it goes to the fail again. So I'm going to change this program with patch program, assemble, jump not 0 to jump 0. Okay, and this should go to the other side. When I say F9 again, just go back and you'll get correct. What you're supposed to do is edit, patch program, apply patches to input file. Okay. That's the solution for the second exercise. I hope that you learn a bit more about assembly. We talked about the call calling a function, and the previous instructions that we wrote will be applied for this function. We talked about pseudocode, compiling the program, creating the pseudocode from the view, changing some variable names, and applying it to the program in order for us to see it better. It's basically all about writing comments and changing variable names in order for you to understand the program better so that you can reverse what's going on much better. Hope you enjoyed this video. Drop a comment. The next video will be on Jira, how to use Jira. It's basically another introduction video by solving a very simple crack me. Cheers, guys.